Okay, so hello, children. Okay, so for today we are going to talk about weathering. And when we talk of weathering, it's not exactly about if it's raining, if it's cloudy, if it's sunny. Nope. Okay, moving forward, there's a fun fact right here that I'm sharing with you guys. And if you want, you can go to the PowerPoint and then try to check on the video that's included there. If you want, you can know more about Peru's Rainbow Mountain and more or less have an idea about the physical and chemical weathering processes that shape its colorful appearance. But for now, we're gonna move on because I don't wanna bore you too much. So eventually, the processes that we will be discussing today will actually delve on the rock cycle. But for this part, we're going to talk about the green arrows only. So again, all of these processes are reflected in the rock cycle. But Miss Lim, what the hey is a rock cycle? So the rock cycle is actually a set of processes that actually generate your rocks, and that each type of rock undergoes different processes depending on its type. So, for example, if it's an igneous rock, it can undergo the arrows right here and eventually turn into different kinds of rock. So each particular kind of rock will have different processes attributed to it, especially with regards to its formation. So different types of rocks, different steps to formation. But enough about that. We're going to talk about the step that forms your sedimentary rocks, or your sediments in this case, which is via weathering and erosion. So with that, we delve into exogenic and endogenic processes with a special focus on exogenic processes. From the word itself, exogenic, what exactly does exogenic mean? To be exogenic means that it happens on the surface because of your prefix exo. So in this case, these are all processes driven by the sun itself. Well, it's not exactly just the sun, but the sun is the main factor to all of this. So this particular presentation will cover the following objectives. So exogenic processes are geomorphic processes. When we say geomorphic, they shape the earth. And that these are processes that are gradational, and that meaning they don't happen in an instant, and that it's usually composed of both degradation and aggradation. In this case, breaking down of materials and building up of materials. And it's all powered by sun and gravity. So in this case, if we are not near the sun, then chances are we won't have all these beautiful formations of mountains and hills. This also explains why planets that are too far away from the sun, like Neptune, Uranus, and what else? We also have Jupiter. It also explains why they don't have a solid surface. It's because they're very far away from the sun, and it's actually the sun that drives the rock cycle or the formation of a solid surface. So when we talk about exogenic processes, they are carried out by geomorphic agents. When we say geomorphic agents, these are factors that actually drive change on the surface of the planet. So these are the following listed below. You could just simply look at it. So these are actually some examples as to how they particularly shape the Earth's surface. So even ice, water, even wind can shape the surface of the Earth. So there are different degradation processes. When we say degradation, it's about breaking down. Break it down. Okay, anyway. So we're going to talk about weathering, mass wasting, erosion, and transport. But for this particular presentation, we're going to focus on weathering and the different kinds of weathering. And when we talk about aggradation processes, we're starting to build up materials. So one example would be deposition and the different examples of deposition processes. So again, we talked about the rock cycle, and that mainly the rock cycle is a combination of different processes that happen in the earth. But particularly, we're going to talk about weathering first, or the degradation processes. So what's so common about all of this? Well, you can see there's always a breakdown of rocks. So these are all processes that lead to breaking down of the Earth's surface, be it weathering, mass wasting, erosion. So they all aim to break down and remove rocks from the Earth's surface. Where are they gonna bring it? That depends as well on the formation of the land. So when we talk about weathering, it's about disintegration and decomposition of rocks on site. Excuse me. When we talk about in situ, it's on site. So there's no transportation involved, and that usually there's a formation of a regolith. A regolith is a fancy schmancy academic term for loose heterogeneous rocks. So they're loose, broken down rocks. They're still in that place and have not been transported yet. So weathering can exist via mechanical, physical means, chemical means, or biological means. And that the idea is that it yields smaller chunks of rocks, or even sometimes particles of rocks. So this begins in small cracks, small joints, small fractures, small faults. Though, just one quick question. Do you think weathering happens instantly? You betcha you're right. It does not happen instantly. Just like any process on this world, it does not happen instantaneously. It takes time. So with that, we're going to talk about the different kinds of weathering in this particular presentation. So we have physical or mechanical, chemical or biological. Okay, so when we talk about physical weathering or mechanical weathering, it's usually brought about by a physical shearing of the rocks. So in this case, think about when you were a little kiddie and you were talking about physical change and chemical change. So in a way, it yields just a change in the shape, in the size, in the bits of the rocks, but not exactly on its composition. So we're not going to change the chemical composition of the rocks. The rock is still a rock. It's not going to change into a different kind of rock. But the idea is that it just gets smaller. There's a reduction in size. So these are actually brought about by higher temperatures and extreme cold and freeze thaw cycles. So these are some examples of physical weathering. Here we have exfoliation, where buried rocks are uplifted and exposed. So usually ang nangyayari dyan, new layers of rocks are exposed. Parang ganon. You also have thermal expansion and contraction. So this happens when there's alternative heating and cooling. So, when rocks, kasi di ba, when it's too hot, objects expand. When it's too cold, objects contract. So the idea is that the continuous expansion and contraction yields cracks on the rocks. Sito ba namang alog-alogin, di ba? Dahil sa init lamig. We also have freeze-thaw weathering. So when we talk about freeze-thaw weathering, water seeps through the cracks in the rock. And remember, when something cools, just like water, it expands. So because of that, the continuous intrusion of the water turning into ice, it expands, it creates a crack. When it melts down, okay, it turns into water. And then eventually, as more water freeze thaws into that cracks, it becomes bigger. So this is an example of exfoliation. So when new rocks tend to expose themselves, so nagkakaroon ng crack on the previous layer of the rock. When we talk about thermal expansion and contraction, here the rocks tend to disintegrate because of the continuous exposure to different temperatures. Well, for freeze thaw, we can see here how there used to be ice here, but because the ice has melted away, that's where we find the thaw. And eventually, if more water starts to seep in here and it starts to freeze, it can expand and create a bigger crack within the rock. So the second process is chemical weathering. So here, there's a decomposition of the rock because of chemical change. So in a way, we're starting to change the composition of the minerals. You change the composition of the minerals, you end up changing the composition of the rocks. Miss, why are you pointing at me? Are you angry? No, I'm not angry. It's just I want to get my point across by pointing. Okay, so again, this is characterized by a change in the composition of rocks. So these are some examples: oxidation, wherein there's a change. This oftentimes happens in iron-rich rocks, wherein parang kalawang, just like rust, it ends up getting a reddish color because of the exposition to oxygen. We also have hydrolysis, wherein rocks with silica end up combining with water, forming clay. There's also biosolution, so natutunaw, the minerals end up getting dissolved, or also carbonation, wherein those rocks rich in carbonate materials containing containing carbonate materials, so they end up reacting with water. So still there's a solution of some sort, a dissolving of some sort. So here, let's look at oxidation. This is characterized by reddish streaks right here. Again, hydrolysis due to the formation of clay materials. So the thing is that if it's not a change of color, oftentimes chemical weathering produces rounded edges because of the dissolving process. So here we have solution. So here, actually, behind the chapel, you'll see the rocks having this sort of appearance because of the continuous exposure to rain. So if you would remember the Chapel of Life, you would look at the rocks behind there. I like going there because you end up observing all three kinds of weathering behind the Chapel of Life and along Calachuchi Walk. Sobrang ganda. Nung, ewan ko, I just like how the rocks are all exposed to all the three factors, you know. It's just me geeking out about the surroundings. And of course, we also have carbonation. So carbonation is just usually for carbonate-rich materials. So just a quick question. Which type of weathering do you think generates sharp cracks? What about rounded edges? So okay, if you answered, you can actually pause the video here if you want before I divulge the answer. Pause. No, I'm not really going to pause as well. But if you thought about physical weathering generating sharp cracks, you're correct. And if you thought about chemical weathering generating rounded edges, then you are also correct. So if you notice, it's because there's only a physical change. It does not necessarily, just like when you tear a shear of paper, because of the physical changes, it ends up with irregular, jagged shapes. But when we talk about when we talk about dissolving, we oftentimes have or we generate rounded, smooth surfaces. Last but not the least is the last type of weathering, which is biological weathering. So this is when plants, animals, fungi, lichens all contribute to weathering. So if you would see here, the tree itself has actually started to infiltrate the rocks. And what happens here is that the roots themselves start to jab at the rocks, changing the shape of the rocks. Now, biological weathering, it's a bit of a combination of both physical and chemical weathering. But the thing that makes it unique is that the cause of the change is a living thing. But the appearance of the weathering can exhibit a likeness to both physical and chemical weathering. We'll talk about that later on the work. So these are just some examples of how they do it. Roots can break rocks or wedge through the rocks. Lichen are the mold-like structures. They are mold-like beings, but they're a combination of fungi and algae living together. But they end up looking like mold, and they're usually found on the surface of trees, and more importantly, rocks. So what they do is that they oftentimes release acids, and what happens is that the rocks can turn yellowish or greenish, depending on the acids released by the lichens. And of course, even burrowing animals, your little gophers, they can also actually promote biological weathering via physical means in this case because they end up scratching around and damaging the rocks with their little paws. So these are just some more examples of trees wedging through the rocks. And this is actually what lichens do. They can actually change the shape of the rocks by dissolving using their acids. So the second part here is erosion. This will be really quick. So when we talk about erosion, if weathering is just breaking it down, erosion is all about moving that broken down rock to different locations via different agents, of course. So these are just different agents. We have flowing water and they yield fluvial morphology. So when this means that they make rocks, or rather they make, they actually make different they make different structures because of the flowing water. We also have winds, tidal waves, and ice glaciers. So these are actually some the items listed below. They are examples of they are specific examples as of agents of erosion. It's just like, for example, potholes and pools. They are specific examples of flowing water and whatnot. So when we talk about fluvial morphology, we talk about how flowing water creates different shapes. If you actually look at river bends, just around the river bend, yes, the Pocahontas song. When we talk about river bends, it's actually brought about by the continuous flowing of water, continuously burrowing and shaping the bow of the river. So we also have this aeolian landscapes or the winds. So here, this is an example of a yardan. So yardans are usually structures that are made by the winds themselves. So ito yung mga areas that are constantly exposed to wind. That's why they're shaped like that. We also have coastal morphology. So what happens here is that because of the continuous smashing of the waves onto these rocks and the water itself contains salt and other minerals, it can also change the shape of the rock and even the color of the rock. And eventually, this actually brings the different eroded materials to other parts. We also have glacial morphology, wherein the ice itself is the drive for transport. So the ice is embedded, the rocks rather are embedded in the ice. And eventually, the ice particles, when they thaw, when they melt, they bring those chunks of rocks with them. So with that, can you think of some everyday phenomenon that's connected to these processes, to weathering and erosion? So this is the part where you're supposed to pause and then maybe I'll wait for your answer. So with regards to, okay, this is the part where we answer the question. So with that, your everyday winds are actually examples of an erosion agent. Rainwater is also an example of erosion, of an eroding agent. And that usually we might not um, we might not be able to observe a variation of phenomena right now because we are stuck in the city. But eventually, as we go around to different areas of the country, we also see how there are different processes that happen around us. And eventually, these processes all shape what that area looks like. Now, sometimes also these particular processes can oftentimes go a little bit too strong, like the earth gets a little bit too excited. And eventually, a lot of people are harmed by this disaster. So, with that, can you think of ways as to how you can help other people? For example, there's too much rain, there's too much flood. All of these are agents of erosion. All of these are agents of weathering. But at the same time, we should probably think of the people who are affected by these processes. How do you think can you help? So hopefully, when we do help, we help from the bottom of our hearts. Particularly during these times wherein there is a fragment of humanity that constantly gets eroded, especially when it's a very troubling time. So, with that, particularly for this time, especially during this pandemic, let's continue to show empathy. Let's continue to show Christ like charity, especially for people whose rights are constantly getting trampled upon. So, if you want to answer the quick check for this particular video, you can feel free to do so. So, it's also in the PowerPoint presentation. Although, just be keen on the following wordings, okay? So, we can actually answer them together right now. So for number one, the type of weathering that changes the composition of rocks. So it's your chemical weathering. Number two, lichens are agents of blank weathering. You're right, biological weathering. Good job. Number three, glacial morphology is a result of blank erosion. So when we talk about glacial morphology, it's brought about by your agents of ice, or in other terms, your moving ice. Oo, nakalimutan ko yung sagot kaya ako bumalik. Oo, I'm human. Well, true or false? Weathering is a process of breaking down rocks in situ or on site. It's true. Number five, hydrolysis is a type of chemical weathering that happens in iron-rich rocks. That's false. This should be oxidation. So hopefully you stuck through to the end of this presentation, and hopefully I will see you next week. Bye-bye.